All right, so we are going to start working on chapter 3, which is going to help us create numeric summaries. Let's be able to explain a little bit more of what's happening with the numbers or the data that we graphed in the previous chapter. Okay, so in this chapter, what we are going to learn how to do is how to find the arithmetic mean, how to find the median, explain what a mean is for what it means for a statistic to be resistant, and then also define the mode. So mean, median, mode, you probably have heard these terms before, but we're going to work with them again here. All right, so determining the arithmetic mean from raw data. So the arithmetic mean of a variable is computed by adding all of the values of the variable in the data set and dividing by how many we have. So if I had 20 different values, I would add all 20 of them together, find their sum, and then divide by 20. Now, depending on what we have, if we have access to the population or if we have access to the sample, we can have a population arithmetic mean or we can have a sample arithmetic mean. Each one is going to have a different symbol to represent whether we have population or sample. So the population symbol is this Greek letter here pronounced mu. And that means if we have every single person in the population. If we've only taken a sample, our mean is going to be X bar here. So again, whichever symbol they give us will tell me, do I have a population or do I have a sample mean? Okay, remember that a population value is a parameter and a sample value is a statistic. Okay, and that was something we talked about back in chapter 1. So no matter whether we are finding a population mean or a sample mean, the formula is exactly the same. All right, so you'll see here, mu or X bar is going to be calculated the same way. Sum all of the individual values you have divided by how many total you have. Sum all the individual values together, divide by the total number that you have. So let's say here, we have given an exam to 10 students that are enrolled in introductory statistics. So we are going to pretend that this 10 is my population. It is the entire class. So that's a population. So first wants us to do is calculate the population mean. Then we're going to find a random sample of 4 students and then compute the sample mean found in part B. All right, so I have 10 scores here. So if I want to find the population mean, I'm going to add all of these scores together to get a total.
In order to find the mean, we start with the sum. All of those values from the previous slide here, we will see summed 82, 77, 90, 71, 62, 68, 74, 84, 94, and 98. In a calculator, I will add those together and click equals before I do the division. I need that entire sum, which is shown here as 790. I will then take that sum and divide by how many data values I had, which was 10. So 790 divided by 10 is 79. That makes the mean score 79. I will always show you these by hand first, just so you can understand the concept, and then we will go back and do these in Statcrunch. So our population mean is 79, and next we're going to talk about how we find a simple random sample of size 4 and calculate the mean of that.
So we have a few different options how we could do this here. I could go to a random number generator because this is the example I'm working out for you. I've already gone through and done a random number generator here. What it has me do here is this is just using my TI calculator here. I want it to give me random integers, no repeats. I have from 1 to 10. So I have all the numbered values 1 to 10, and I want to select 4 of them. So I used my TI-84 to give me a random sample of 4 numbers from the values 1 to 10. Okay, and the values it spit out were 5, 10, 2, and 6. So I go here, 5, 10, 2, and 6. Those are the scores I'm going to use. 77, 62, 68, and 88. And these are the 4 that they have. All right, so now it wants me to find a sample mean using my 4 randomly selected values. So to find a sample mean of these 4, I'm going to sum the 4 values together, and I get 295. I take that total divided by how many students I selected, which was 4, and this is my sample mean. Okay. Notice my sample mean is not the same as my population mean. It's because I've randomly selected 4 values. If I pick a different 4 random values, I will get a different sample mean. Okay, so I could run that again. So I'll run it the other way here. Random organizer. So this is what I did last time. All right, so we have first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10. I have 10 students. So what I'm going to do is I'm going to randomize it, and I'm going to take the first 4. Okay, so we're going to take students 6, 9, 8, and 4. I'm going to get a different mean. All right, so we've got 6, 9, 8, and 4. So let's see who those are. Okay, so I'm going to pick a different color here. All right, so I got 6, 9, 8, and 4. All right, so what I'm going to do is I'm going to just grab my basic calculator, and I'm going to add my 4 values. 71, add 68, add 84, and add 94. Okay, when I sum those 4 together, I get 317. Divide by 4. This random sample has an average of 79.3%. So each group of 4 random samples I'm going to get is going to give me a different sample mean because I'm using 4 different values. To find a mean, you're just going to add all your values together, divide by how many total you have. And since we're not in class, we can't do this activity. I'm going to move on here. All right, so next is a median. The median of a variable is the value that lies in the middle of data when it is arranged in ascending order. Okay, we use capital M to represent the median. So what you will have to do is arrange the data first in ascending order. Determine how many there are so that you can get to the middle of the data set. Okay, so what's going to happen is usually the way that I do it is I put them in order and I kind of cross off until I get to the middle. The other way you can do that is take your data, and if it's odd, then the median is the data value exactly in the middle of the data set. That is, the median is the observation that lies in the n+1/2 position. Okay, so we'll go through this on the next slide here. Okay, So this is an odd set of numbers. This is the length in seconds of a random sample of songs that was released in the 1970s. We're going to find the median length of a song that would have been released in the 1970s. Okay, so in order to do this, I first have to arrange them in ascending order. So I'm going to find the smallest, and I'm going to list them in order from smallest to biggest. 179 is the first one. That's the second one, third one, fourth one, fifth, sixth, 7, 8, and 9. So I'm going to put them in order here. 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So there are 9 observations. So what I can do is I can use that formula, n plus 1 divided by 2, to tell me which value is in the middle. I don't have to use this formula, but I'm just going to show you how you could. So there's 9 pieces of data. Add 1 is 10. 10 divided by 2 is 5. The way I prefer to do it is they are in order. So I just cross off 1, 2, 3, 4 from both sides, and that leaves 1 in the middle. This is the middle because there are 4 values here and 4 values here. Okay, so I prefer the cross out method versus a formula. I don't have to worry about a formula. It's just a matter of crossing off to get to the middle. What happens though if there is an even amount of data? So let's go back to those 10 test scores. We have 10 of them here. Okay, and I would have to start with putting them in order. So first one, second, third, fourth, fifth. What are we at? 6, 7, 8, 9, 10. And I would list them in order then. Okay, I've already done that on this slide here. So they're all 10 in order. So the way that I do it is I just start crossing out. 2 on each side, 3 on each side, 4 on each side. Okay, now I can't cross out anymore because if I cross out one of these, I'm left with an uneven amount. It has to be even on both sides. Okay, so because n is even, the median is the mean of the 2 middle observations here. So I need to take the 5th and the 6th and average them together. So 77 plus 82, I get that total first. So 77 plus 82 is 159. Divided by 2 gives me that 79.5. Okay, so what I'm saying here is the median is 79.5. And then I have 1, 2, 3, 4, 5 data values below it, and 1, 2, 3, 4, 5 data values above it. So now we're going to compare the mean and the median, because sometimes they are very close together, sometimes they aren't. Okay, so Yolanda wants to know how much time she typically spends on her cell phone. She goes to her phone's website and records the call length for a random sample of 12 calls. Shown below in this table, we want to find the mean and the median length of phone call. And then which measure of central tendency better describes the length of a phone call? So if I were to find the mean, I'm going to add all those together. So 1 plus 7 plus 4 plus 1, 2, 4, 3, 48, 3, 5, 3, and 6. Okay, that gives me a total of 87 minutes that I'm going to divide by 12. And my mean is 7.5. Median, I have to put them in order. So 1, 1, 2, 1, 2, 3 threes, 3, 3, 3, 4, 4, 5, 6, 7, and 48. All right, so what I'm going to do is I'm going to work my way through here by crossing out 1 on each side, 2 on each side, 3 on each side, 4 on each side, 5 on each side. Okay, I'm left with 2 in the middle. So if I add 3 and 4 together, that makes 7 divided by 2. The median is 3.5. Okay, so these values are quite different. The median is saying I spend 3.5 minutes on a phone call. The mean is saying I spend 7.25 minutes on a phone call. Okay. On the following screen, it's just another example here of what we have. It also gives us some other values that we'll eventually talk about here. But there were 12 values. Here's your mean. Here's your median. And then you have a dot plot here. Okay, so the mean 7.25, median 3.5. So the question becomes, well, which one's better to represent our typical call length? So here's the thing. We have this one value really far out here. And when I calculate the mean, what happens is this value is accounted for, okay? So this one really long phone call skews the rest of my data. The rest of my data is between 1 minute and 7 minutes, okay? Most of my phone calls are between 1 and 7 minutes. This one value pulled my average up above 7 minutes. Okay, so when you have a data value that's really far away from the rest of them, that value pulls your mean up, or in some cases down. If that one data value is really low, it's going to pull your average down. So in a case when you have a data value that's really far out, the mean is not going to be representative of that data set, what we want. So in this case, a median is going to be better. So what does that mean exactly? Why do we discuss this? Okay, we talk about the word resistance. And what's going to happen is the one that is most resistant here is the median. A median is going to be resistant because it does not get skewed because of a really high or really low value. So in this case here, this value throws off my mean. So mean is not resistant here. The mean is impacted by these values. The median is not impacted by these values, so the median is resistant. So just to show you, and we kind of talked about those here in these general histograms, shapes of graphs that we talked about in chapter 2, this is going to show you why we get a bell curve versus a skewed curve. In a skewed left, there ends up being low, really low values that are away from normal. So it pulls the mean down lower than the median. Okay, when your mean and median are roughly equal, you get that bell-shaped curve. This phone call set is going to look like this. I have this one really, really high value, so it's pulling my mean higher while my median is lower, and that creates the skewed right diagram. Really just describing a little bit more of why these graphs happen. And it's usually because of those, we kind of call them outliers, or really far data from the rest of the data. On this one here, we have the birth weight in pounds of 50 random sampled babies. We're going to find the mean and the median, and then be able to describe the shape based on just the mean and the median. Okay, so no, if the mean is smaller than the median, it's skewed left. If they are equal or roughly equal, we are symmetric. If the mean is larger than the median, we are skewed to the right. All right, so we're not going to hand calculate this. I'm just going to show you on the previous slide here. If you had a TI-84 and you wanted to run your summary stats, this is how it would spit it out. I will go through and show you how to do it in Statcrunch here. The mean is 7.49 and the median is 7.35. Okay, so these two values are really close to each other. If I were to draw my graph here of my histogram, here's my mean, here's my median, and they're really close to each other. So we would say this is roughly symmetric. And when they are symmetric, we use the mean. That is our go-to. If it is not a symmetric, we will no longer default to the mean and we will instead choose the median. So we usually like to default to the mean. That is the one that we like to stick to the most. But in a case that our data is skewed one way or the other, we will switch to then explain that the median is better representing of our data. The last thing we're going to talk about is what is called a mode. The mode of the variable is the most frequent observation of the variable that occurs. A set of data can have no mode, one mode, or more than one mode. If no observation occurs more than once, we say the data has no mode. All right, so an example here. The following data represents the number of O-ring failures on all space shuttle flights prior to the fatal flight of the Columbia that was in 1986. Here's all our data. A whole ton of zeros, 1, 1, 1, 3. All right, find the mode number of O-ring failures. Well, what number occurs the most? Okay, I would tally it up if I wanted to, or visually I can really see this here. 0 happens the most frequently. These are all zeros. There are way more zeros than any other value, so the mode is 0. Let's look at the test score data. Okay, this was our test score data. And if you look at these, okay, so I've got an 82, a 77, 90, 71, 62. None of these values happen more than another. So this is an example of no mode. There are cases where there is no value that happens any more frequently than another one. And in that case, we say there is no mode. Note again that a data set can have more than one mode. It is possible. If there are 2 modes, that would be called bimodal. So for example, if I went back here and I did this, I changed this one to an 82. The mode would now be 82 because 82 happens more than any other value. Okay, if I go and do this though, I have 2 values that occur more frequently than any other value. And it would now be bimodal 82 and 90 because both 82 and 90 happen twice, which is more than any other value. It is possible to have more than that if you're working with a really high amount of data. So if you have 3 or more, it is then called multimodal. Most of the time, we're not going to see data that does that. It'll usually be just 1, none, or 2. But do know that that can happen. Okay, so what if, though, I don't have number data? What if I have qualitative data? And this was a data set that we worked with in chapter 2. So the data in this table represents the location of injuries that required rehabilitation by a physical therapist. Determine the mode of the location of the injury. Okay, this is a frequency table. It is telling me how many times a person listed this response. Okay, so the mode is by definition the most frequent. So the one with the highest frequency is the mode. So the highest frequency is 12, and that is the value of back. So the back is the mode. Okay, this is qualitative data. The response was back, hip, shoulder, back. A word response. That word data can be put into a frequency table, but it is still word data. So question is, can you calculate a median or a mean from qualitative data? Can I find the average body part that I do physical therapy on? No, that doesn't make any sense. Can I find the middle value of body part that requires physical therapy? No, it doesn't make any sense. So even though I may have frequencies and you see numbers, qualitative data can only have a mode. We can never discuss a mean or a median with qualitative data. Word data can only have a mode. To recap here, our mean, add all of them up, divide by how many you have. When to use it? When our data is symmetric. Okay, median, you're going to put it in ascending order. Find the value that is in the middle. So what it does is it divides the data into exactly 50-50. We will use it if we have skewed data. If we have skewed data, the median is the best representation of the center. Okay, the mode is the most frequent occurring. And if you want to know what is the most frequent option, you're going to use mode. Or if you only have qualitative data, the only one you can use is mode. Okay, so how do we do this in Statcrunch? Because right now we've only talked about this, how I do it by hand. All right, so I already have my Pearson open here to my course homepage. So if you have not gotten there already, you go ahead and navigate to Blackboard, open your Pearson MyLab home, because I'm going to go to Statcrunch and open up a data set. So I'm going to click this top one here, which is view data sets from the textbook. And we are in chapter 3. So what I would like you to do is open up 3:126. And this is data for the length of eruption. Now, if I remember correctly, this is the length of time between eruptions of Old Faithful. I believe that's what this one was titled. It's hard to remember which one's which, but I think that's what this one was for. All right, so if I want to be able to find the mean, the median, and the mode, because I have number data, I can do all 3. All right, so I'm going to go to Stats, Summary Stats, and Columns. This is how I'm going to do everything for chapter 3. Okay, what I'm going to do is I'm going to click the option here. I'm going to put it over here. and it is going to spit out this lovely table here. Now, it will spit out the mean and the median. The mode will have to be calculated looking at a dot plot or a bar graph. So the mean is 104.1. The median is 104. So hey, they are both really, really close together. I'm going to assume that this is probably some symmetric data here. So if I create a bar graph or a dot plot, it should look pretty symmetric. So let's do that here. Let's do a dot plot. Dot plot for the length of eruptions. All right, not too bad. Oh, I like to make my dots larger so that I can see them. Because I have a hard time viewing them there. There we go. Pretty overall kind of symmetric here. So the last thing we want to find is our mode, or the tallest one of these. So if I'm looking at this, it actually looks like this one is the same height as this one. Hovering over that, 103 happens the same amount of times as 110. So 103 and 110 would be my mode. So mean is 104.1, median is 104, mode is 103 and 110. There is another way you could do that here. If you go to stat, summary stats on the column, you can just go down here and select mode and only find the mode. Problem is though, if there are multiple modes, it's not going to give it to you. Okay, so that's why the bar graph or a dot plot are better at showing you that. So I could go to bar with data. It's going to be the same as a dot plot. Oh, except that it's going to bin it. I don't want to do that. So dot plot is the best way for this one because I have a ton of data. So go back to my dot plot. Dot plot's going to be your best bet because if you have a large set of data, it's not going to like making the bar graph for you. It's going to want to make a histogram. Okay, so we said mean was 104, median was 104, mode was 103 and 110. So if I had to pick one of them based off of, hey, what's the best measure of center here? I'm going to go with the mean because it's relatively symmetric, and that is the best one to pick what if you are just asked for what's the best and it's symmetric. And in this case, the mean and median are the same. So really, it didn't matter which of them I chose. They're both 104. All right, so let's say though, instead I wanted to look at this data set 3129. And this is political view of 30 different people. All right, so I have word data. This is qualitative data. I cannot calculate a mean. I cannot calculate a median. I cannot do that. If I go to try to do this, stat, summary stats, column, it isn't even going to let me select it. I cannot calculate a mean or a median. It is word data and it sees that. Okay. The only thing I can do here is create a bar graph with my data and see which one is the highest. And the highest in this case is moderate political views. So moderate would be my mode. You guys have your choices. You can do them by hand. You can use Statcrunch here to help you. Everything we're going to be doing in here is stat, summary stats columns, and then creating either a dot plot or bar graph depending on what you have. I would use a bar graph for the word data, and I would use a dot plot for the number data. just because it doesn't like if you have a huge data set to do a bar graph. That plot is better. Well, that is the end of section 3.1. I will see you back here in 3.2.